Welcome students in our next video, and this is a video of class 11th, and the topic is laws of chemical combinations. Laws of chemical combinations. Chemical combinations. Laws of chemical combinations. As we know that when we go on the road and run on the road or walk on the road, when we drive vehicle on the road, there are some rules which we'll have to follow. We will have to we will have to walk, we will have to run the left side, we will have to wear helmet or seat belt, or many other rules there will be to follow on the road. So like this, here are some rules which a chemical reaction have to follow, chemical equation have to follow. Those rules are called laws of chemical combinations. There are certain set of rules which a chemical reactions have to follow, and those rules are called the laws of chemical combinations. We will not make them to follow. These chemical reactions automatically follow these rules, and we only study that how these chemical reactions follow those rules. And we observe that the chemical reactions follow, there are some rules. What are rules? First rule, law of conservation of mass. Law of conservation of mass. Second rule is law of definite or constant proportions. Law of definite or constant proportion. Third rule is law of multiple proportions. Law of multiple proportions. Law of multiple proportions. And the next rule is very easy name, Gay-Lussac law of gaseous volume. Gay-Lussac law of gaseous volume. There are mainly 4 laws which a chemical reaction have to follow. Laws maybe in other books, maybe 5 laws, reciprocal constant. But here we will study about 4 main laws which a chemical equation have to follow these laws. So first, what is the law of conservation of mass? What is the law of conservation of mass? We will study one by one. Law of conservation of mass was given in some books year 1774 and in some book 1789. And law of conservation of mass was given by a French chemist. Do you know French chemist? That is named Antoine Laurent Lavoisier. Antoine Laurent Lavoisier. Antoine Laurent Lavoisier. Antoine Laurent Lavoisier is also called the father of modern chemistry. He gave the law of constant proportions. What is this law said? During a chemical reaction or chemical change, the total mass of the product obtained should be equal to the total mass of the reactant. The total mass of the product, the total mass of reactant should be equal to the total mass of product. Total mass of product. In other words, we can say total mass of product should be equal to the total mass of reactant. And how, when it will become possible? It become possible only when that neither matter can be created nor be destroyed in a chemical reaction. We can't create a matter and we can't destroy the matter. We only can change the state of matter. We can only change the state of matter. So this is possible when only when matter is neither created nor be destroyed. However, it may be changed from one state to another state. And we take the example formation of carbon dioxide from carbon and oxygen. That no, the equation is this: carbon, oxygen and carbon dioxide. We will prove this law by this example. By this example. How we can prove this example? Let's see. Do you know the atomic mass of carbon? What is the atomic mass of carbon? 12. Do you know this equation is balanced? Yes, balanced. Here carbon 1 atom, here carbon 1 atom, here oxygen 2 atom, here oxygen 2 atom. So this equation is a balanced equation. Now the atomic mass of carbon is 12 and what will be the atomic mass of oxygen? Here oxygen 2 atoms. So one atom of oxygen contains 16. So 2 atoms will be 32. And if we equalize that 48 gram. And what will be the mass of carbon dioxide, which is the product? So in this 12 plus 16 into 32, 16 into 2, that will be 12 plus 32 and will be, something wrong in calculation, 34 is this will be 34 and here will be also 44 gram. Here we see that this is the reactant and this is the product. These are the reactants, carbon and oxygen is reactants and carbon dioxide is product. Here we notice that the total mass of reactant is equal to the total mass of product. So this law says that in a chemical equation, the total mass of product should be equal to the total mass of reactant. This law was given by Sir Anthony Laurent Lavoisier in the year 1774. And Anthony Laurent Lavoisier is also called the father of modern chemistry. A student, from this law, we see that many objective questions are cleared by us. Many questions. First, what is law of conservation mass? When it was given? Who gave the law of conservation of mass? And what is the example of conservation of mass? And Anthony Laurent Lavoisier is the father of modern chemistry. A question can be asked, who is the father of modern chemistry? Anthony Laurent Lavoisier. Now we come to the next law, that is law of definite or constant proportions. Law and constant proportions. Law of definite or constant proportion was given in the year 1799. And this equation was given by, this law was given by scientist Prost, James Prost. The student, you should know that Lavoisier and James Prost were French scientists. What is the law of definite proportion says? The law of definite proportion says that a chemical compound always contains the same element compound together in fixed proportions by mass. What says? Let's understand. The chemical compound has fixed composition and it does not depend on the method of its preparation or source from which it is obtained. If we have chemical compound, then It will not depend from where it is obtained, what is the source of this, where it is gained. So it is the proposition, the composition of the elements in the compound will always be same, will always be definite. So this law is called law of definite proportions or law of constant proportions. So let's see with the example. For example, if we take water, or water, suppose if we take water for example, water, if you get the water, if you get from America, if you get water from India, if you get water from France, if you get water from Nigeria, if you get the water from Pakistan, if you get the water from Norway, water from anywhere, the source may be anywhere, the place may be anywhere, but the chemical formula of water will always same H2O. If the chemical formula of water is same, then the mass will also same. Mass will be hydrogen mass 1, 2 plus oxygen 16. So here will be oxygen O2 16 to 2 and H2, sorry, H2O, not O2. So here will be 18. Why? Because 2 plus 16 will equal to 18 gram. The mass of water of one molecule of mass of water will always be 18 gram and it can't be changed. The source whatever be, the place whatever be, but the compound of water will the formula of water will always be same. The law of definite constant proportions means H2O 1, sorry, the ratio will be 2:1 of hydrogen, 2 atom of hydrogen and 1 atom of oxygen. This will be the ratio. So this law says that the compound has fixed compositions and it doesn't depend upon the method of its preparation, how the water is formed, natural source or formed by hydrogen and oxygen in laboratory. The compound formula will remain same. And third law of multiple proportions. We come on the third law of multiple proportions. Law of multiple proportions was given in the year 1803 and you know the name the scientist Dalton. John Dalton. John Dalton was the scientist who gave this law. According to this law, if two elements combine to form more than one compound, then the masses of the element combined with a fixed ratio of other element will be in simple whole ratio. For example, if two compounds are formed from same elements, suppose H2 and H2O2. This is water, this is hydrogen peroxide. Both are forming from H2 plus O, and this is forming from H2 plus O2. From this beginning the water. What should I do? If we notice that hydrogen atomic number here is 1:2 and 16, here 1:2 and 16 into 2. The element of hydrogen will remain same. 2 atoms of hydrogen here participating, 2 atoms of hydrogen participating, but here oxygen atom 1 participating, but in hydrogen peroxide 2 oxygen atoms are participating. So here will be the other element which are not in same ratio, which not in same amount, that will be in whole number of ratio, means 1:2 means 16:32. Here 32 and here 16. The mass will be 16 and here 62. So this is the law of multiple proportions. If two elements forming more than one compound, here 2 elements same hydrogen oxygen, same hydrogen oxygen, same hydrogen oxygen, hydrogen and oxygen, 2 elements are forming 2 different compounds. Then the the element which are taking participate in different ratio will be the in same in equal ratio, equal simple ratio. And small whole numbers, the ratio will be small whole numbers. According to this law, if two elements or can combine to form more than one compound, the mass of the one element then combined with the fixed mass of other element are in the small whole numbers, small whole numbers. Ratio is small whole numbers. And the last law of that is given Gay-Lussac by 819. Gay-Lussac gave the law in 1808. This also was the French scientist. And what he said, Gay-Lussac observed that when gases combine or produced in a chemical reaction, they do so in a simple ratio by volume. Here by mass, here by volume. For example, hydrogen, chlorine, they form HCl. And for balancing 2HCl. Here one volume of hydrogen combining one volume of chlorine and producing 2 volume of hydrogen chloride. So this is the example of Gay-Lussac law of gaseous volume. He said that when gases react, they react in the form of volume. And equal volume on the same temperature and pressure have the same number of atoms or molecules. This law was given by Avogadro. So this was the laws of chemical combinations. I think you understood many important things of this law. Okay, thank you, students.